Alright, gonna do another video of this, just to show you the power of rebuilding the IAT. You know, that was the whole point of that playlist. But anyways, so I want to reverse today. I'll show you today reversing Battleye's pre-POB pre-operation callback. Which, if you don't know, is a callback which you can register with your kernel driver to get notified anytime there is a process or thread handle operation. Now, so if you have a thread or if you have your process like this and if you have code which calls open process, the callback will get notified for that. Or if you're doing ZW open process from your driver. Anyways, so here, as you can see, I've oh, by the way, I found this is in WinDebug I did with my dump. I did DT object type POI process type, and then I got the callback list. Clicked out the callback list. I went through the linked list. I already know it's this one because I looked at it earlier. I just did this again for you to see. But which one was it? Uh, yeah, this one. So these are the actual callback objects that represent the object register callback that is allocated. It's not exactly this structure. It's its own structure. But if we look through that structure, um, you will find I think it was this one, this address, which is in the binds of Battleye. I mean the binds, yeah, in the binds of, let's see, LMMBE Daisy. Look, 8076BA, 8076BA, right? Bounds. Sorry, what the fuck am I saying? Binds, bounds. It's in the bounds of BE Daisy. If you go there and we go here, we'll be back here, which is this one. So, anyways, enough of WinDebug. So what they first do is, and remember I rebuilt their whole import address table, or their data section in this case, but whatever. First thing it checks is if the operation information is 1 or 2. If you don't know, you can just click on this one. This is the operation it's checking. It could either be a handle create or handle duplicate. Handle create is 1, handle duplicate is 2, so it's checking if a handle is being created or duplicated. Then it's setting v9 to the address of operation information plus 4, which is just 1, 2, 3, 4. Sorry, I mean fuck. 2, 3, 4. So the parameters, right? So I was looking at the. So sorry, I said that wrong. This is. I said that completely wrong. Um, yeah. So this is 4. Parameters is 4. I don't know why I said that wrong, but anyways. And what it's doing is it's casting it to a pointer, dereferencing that value, and then casting it to a dword pointer. So now whenever v9 is modified, the address containing the value operation info plus 4 is modified. Keep that in mind, right? So v9 is the permissions, okay? And these are obviously uh, all of these. So yeah, anyways, it says v9 to that address. I guess I can rename that to um, what's it called? Parameters pointer. Whatever, it doesn't matter, right? Anyways, and then we go down, we check if object type is equal to operation info plus 4. Then we check if that's not a process type. We're assuming for this reversing it is. We are creating a handle on a process. So let's say this process is creating a handle on a Battleye protected game. So it'll ignore this whole if statement here, and we'll go down here. Object handle 1, again I've renamed these, is equal to operation info plus 1. If you check object, so that's the object the handle is being created on. So it's checking if object handle is equal to, I'm sorry, if R6 PE process is equal to object handle. So if the process handle that's being created is being created on Siege's PE process. So if open process is called on Siege, then obviously this will evaluate to true. So we'll jump to label 15. Here this byte is set, we'll ignore that. And then it's checking if Siege itself is creating the handle. Operation info plus 1 is equal to PS get from, and we're assuming this is not the case because this just goes to label 95, and label 95 doesn't do anything, right? Or it just returns basically. It looks like it returns. They probably do some other checks there. Here it's checking if operation info indexing into the first array and 1 is not 0, so that would be operation. So if this is a kernel, or sorry, not operation, this would be the union, flags, and the struct. So if it is a kernel handle, we're assuming it's not a kernel handle. If it is a kernel handle, it again just goes to label 95 where it does this bullshit. Well, actually, it doesn't do this bullshit because it's a kernel handle. So label 95 is this one. What am I saying? And it just returns. So again, we will ignore that case. Um, where the fuck was I? Shit. I think I was here. Yeah. Anyways, so we're ignoring. Yeah, label 15. Okay, so we're ignoring this, and we're going here. We're getting the current process ID. We are checking if not v10. I'm also gonna, um, I'm gonna ignore this stuff, right? Because it's really not important. If we go to label 15, yeah. I mean, all of this is a guessing current process ID. It sets some information, and it goes to label 91. If anything goes to label 91 or 95, you want to just ignore it at the start, because those just return. They don't do anything. So, and plus I'm not sure what these are. I've just went in and I've checked what these global values were at the time of dump, and I've renamed them. Some interesting stuff. I guess Battleye checks if the current thread ID is equal to not my fault TID. It was pretty interesting stuff. I'm not sure why they do that. Maybe they flag you if if you're using not my fault. Maybe this is something weird that was loaded, and it's not always not my fault TID. I don't know. We're ignoring that. I want to look at the interesting stuff. So this isn't anything new, by the way. This is anti-cheats have been doing this for a very long time, but it's cool to learn. Anyways, so it checks if there is not a global CSRSS PID, which let's assume here there's not. So CSRSS, if you don't know, CSRSS and LSAS are Windows processes that require a handle on every single process on Windows. So what anti-cheats will do, actually I'll explain it right here. So we check if there's not a global CSRSS, if not this, so 0, we're gonna ignore that. And if current process ID does not equal CSRSS. So let's pretend this is the first time that CSRSS is creating a handle on our game. String copy CSRSS to v51, gets the current process, and then it gets the image file name of the current process. It compares if the current image file name is CSRSS. If it is, so CSRSS is creating the handle, we get the current process. It calls this function. This function needs to take more arguments. I kind of fucked up the stack frame for that. Um, but we'll ignore that. I fucked up the stack frame for that. Anyways, v16. So maybe this function does some checks on CSRSS. Maybe it compares the in-memory CSRSS to the one on disk to see if something's been tampered or messed with. Maybe it checks some stuff with the current call context, this function, whatever. The important thing is when we go to label 70. So v16 is set to this. v16 is set to some global variable. Not sure what that is. Then we go to label 71. Now this is the interesting stuff. So our parameter pointer is dereferenced and it is stripped of handle rights. Now CFD, I'm not sure exactly what this is. I'm pretty sure it just takes off. It strips VM read write and let me see. Hold on. Go here. Access mask. CFD. I'm pretty sure it strips these ones, and I mean you can literally just convert that to binary and then look at the bits. I'm not gonna do that. I'm too lazy. Basically it strips it of anything that's not this stuff. This is an example I made. So with this program, I created a handle on a Battleye protected game, Siege, and as you can see, I did process all access, right? But this callback, as you can see, stripped the rights to process terminate, all of this stuff. So it took away read write, some query rights and allocation rights, the stuff that you would use for reading and writing and injecting memory. So, but anyways, so that's the CSRSS case. We strip our rights, the handle rights, and we go to label 91, where we just do some more work and we return. Now, same thing with LSAS. If it's not CSRSS, if it is LSAS, we will go down, blah blah blah, same shit. Basically, we do this, probably some check function. We set a global LSAS PID, then again, we strip the handle rights and we go to label 91. Now here, um, this is in the case where the game is being closed. So one thing it checks is if PS get process inherited from unique process ID is equal to R6 PID. So if the process was created by Siege, if the parent process of the current process context is Siege, if it's Unity crash ant, crash report CLI, crash bad handle, um, and if it's those ones, that's what this is evaluating. And something interesting is this return here, this V50 seems to be a structure, and its fourth element is actually set to 0 because this is a cleanup function. So don't worry, you're not going to be clever and create these processes. First of all, because their parent has to be Siege, you can't just create a process with this name. Second of, this immediately initiates a shutdown process for the protected game. So V54 set to 0, we get our process list mutex, right? And then I'm pretty sure we free it. Okay, yeah, so process list, let me see. Anyways, so the global R6PE process is set to 0, the PID is set to 0, R6 parent is set to 0, X free pool, some more cleanup, and when we go to label 91 with V54 fourth element being set to 0, I'm sure that will shut the game down. But the interesting thing is that the handles are not stripped for these three. Ever, because if you go through this function, we just sort of go to label 91 and we don't strip the handle rights for these ones. Now, same shit here, we strip the handle rights. We do it differently though. We do FD5, I'm not sure, again, you can just go check it. Just turn this into bits and check what handle rights are being stripped. I don't really have the time for that. Now, this is the case of the handle being created by an unknown process. This is the most interesting part, right? Because if you remember, all of this is under that if statement. All of this is under the if statement where the handle is being created on Siege. And this is the case if the process which is creating the handle on Siege is unknown. It's not this, it's not these, it's not LSAS, it's not CSRSS. So, like this one. Now, if that is the case, we strip even more handle rights, it looks like, right? BC5, look at this. There's 2 here, there's 3 there. Maybe I shouldn't have been lazy and I should have checked it before the video. I don't care. Anyways, so we strip those handle rights. We go to label 91. We check if it's not a kernel handle, which it's not. We do this stuff, and we return. The snack frame is fucked up for these, so don't worry if these just look like random function calls or not. Then we go here and can't really reverse that further. Gonna need to do dynamic analysis for that one, but It's pretty cool though. Oh, also I missed this if statement. This one checks if a handle is being duplicated. Actually, this is interesting. Don't worry, they're not done. They're not only checking handle creation, they're also checking duplications. So if the operation information, so let me go back. So if it's not one, so if it's duplication, if a handle is being duplicated to Siege, if you're trying to, for example, duplicate CSRSS's handle, or if there's another process for some reason that has handle to Siege and you're trying to duplicate that, and if the current process is equal to CSRSS, so it's safe, or if maybe this is some global safe process, I don't know. Then we go to label 70, and label 70 I'm pretty sure strips the writes, but it doesn't strip all the writes, right? This is at CD. If that's not the case, if a handle is being duplicated from an unknown, untrusted process, then we what's it called? We skip this whole fucking thing and we just strip all the writes. Or we strip more writes, I'm pretty sure. Actually, let me pause the video and how do you pause it? Okay, I'm back. So I went and actually checked the bits myself. Um, with unknown processes, BC5, the handle writes which are being stripped are create thread, VM operations, so virtual management operations, or virtual memory operations. So if you're trying to allocate memory, VM read, VM write, and process query are all stripped from unknown processes. Which is the case in this picture, which I showed you earlier. This is a process handle which I created on Siege with process all access. But yet, when I query my handle object and I check its writes, I only have terminate, set session, and all this other stuff. But I don't have read permissions, I don't have write permissions, I don't have query, and all of this stuff. So that's, I guess that's it.